Good morning, everyone. Today, I will present my review to case study on COVID 19 using Python data analysis. The goal of my study was to analyze different aspects of pandemic, including new deaths, recovery trends, vaccination progress, testing capacity, and government policies using real data sets. For this, I used our world in data COVID-19 dataset and a global vaccination dataset. I then applied Python libraries such as Pandas, Seaborn, Matplotlib, and Plotly to clean, analyze, and visualize the data. Let me now walk you through the analysis step by step. First, I imported the required Python libraries. Pandas was used for data handling, Seaborn and Matplotlib for graphs, and Plotly for interactive maps. Then I loaded a two dataset and converted the date column into date-time format. This step was essential for sorting and filtering the data based on time. Without it, time series analysis would not be possible. I started my analyzing global new daily deaths by grouping the dataset by date and summing across all countries. I created a line graph showing the waves of the pandemic. We could clearly see huge spikes in death during major waves, especially in 2020 and 21, which aligned with the Delta and Omicron outbreaks. I also plotted a histogram showing the distribution of deaths. This revealed that while many days had moderate deaths, certain days showed extremely high values, highlighting the devastating impact of peak waves. Recovering trends using active case proxy. Since recovery data was not directly available, I used an active case proxy, total cases minus deaths and fully vaccinated people. I applied this method to India, USA, and Brazil. The line graph showed active cases peaking sharply during outbreaks but then declining as vaccination campaigns expanded. This comparison made it very clear that vaccination was key to recovery, reducing the number of ongoing active infections in all three countries. Fastest vaccination coverage growth. Next, I analyzed vaccination growth. I calculated vaccination rate as a percentage of total population and measured the speed of increase over time. The top 5 fastest countries were then plotted. Their graph showed very steep rises in coverage, reflecting rapid rollout. Additionally, I used Plotly to create a world map of vaccination rates. This revealed a striking inequality. Countries in Europe and North America had very high coverage, while many African and poorer nations lagged far behind. COVID 19 test analysis. Testing was another key fact in controlling the spread. I calculated the number of tests per 1000 people as of December 2022. From this, I identified the top 5 countries with the highest testing rates. These were mostly high income nations that had the resources for widespread testing. To make the analysis more powerful, I created a choropleth world map using Plotly. This map shows the latest available data for the tests per 1000 populations across all countries. As we can see in the visualization, darker shades of blue represent countries with higher testing rates, while lighter shades show lower rates. The map highlights the global disparity in testing capacity, with wealthier regions testing much more than developing ones. This is very important because without proper testing, it is impossible to identify infections early or implement effective control measures. The next part of the analysis was about government response. I studied the stringency index, which measures how strict policies were, such as lockdown and travel restriction. For India, the USA, and Brazil, the line plot showed government tightening restriction during waves and relaxing them later. A histogram of stringency across all countries showed that while most countries had moderate policies, some period has extreme lockdown, especially in 2020. Finally, I studied G20 countries' vaccination progress by mid 2022. To do this, I filtered vaccination data set for records before July 2022 and kept only the latest entry for each G20 country. Then I created a summary table showing each country's vaccination percentage per 100 people. The bar chart revealed the interesting patterns. Countries like Canada, the UK, and South Korea had very high vaccination rates above 80%, while others like South Africa, Indonesia, and India were comparatively lower. This analysis showed that even among the world's largest economies, vaccine rollout speed was highly uneven. To conclude, this project highlighted multiple aspects of COVID-19 pandemic through data-driven insights. The key findings were deaths spiked during waves but gradually declined with vaccination. Vaccination played a crucial role in recovery but was distributed unequally across the globe. Testing capacity was far stronger in high income nations and compared to developing world. Government stringency fluctuated with waves, reflecting the balance between public health and economy. Even within the G20, there were a large difference in vaccination progress. Overall, this study shows the importance of data analysis for understanding a global crisis. With the with the right data, we can see the pattern clearly and learn the valuable insights for the future. Thank you.